Can you guys spot which one is the improper integral? So hello guys, today I'm going to solve 3 integrals because I got bored of solving just one. So in this video I'm going to solve 3 integrals, and can you guys see which one is the imposter? Which one that you cannot just crisscross, what I'm saying, right? The one that you can't just simplify it easily. Well, to solve that, I need to solve the questions first, right? So I'm going to solve the first question. What is this? So this is the integral of x squared minus 9 over x minus 3 dx from 0 to 2. We know that x minus 3 is the denominator, and you guys know, right, the denominator cannot be 0 because you can't divide by 0. So x minus 3 cannot be 0, right? That means x cannot be 3. But does that matter to our case? We're just evaluating from 0 to 2, right? So it doesn't really matter because we're evaluating at a point where this is not in the integral. So we should be safe to just integrate this normally. So x squared minus 9, we can factor it out with this rule. As you can see, guys, this rule, which is just typical, a squared minus b squared, that's really just middle school stuff. You guys should know it. So I can just solve this one like this. So it's just, and because this is safe to crisscross, we can just do that. So this is gonna be the integral of to the 0 of x plus 3, right? And then after having this, we can just continue integrating as normal. So it's just gonna be x squared over 2 with the power rule. A constant is just a constant with the variable. We evaluate this from 2 to 0, but because 0 is practically like 0 plus 0 is 0, so we don't really need that. So you can just substitute 2 in. So 2 squared over 2, that's just 2 plus 6, so this is just equals to 8. So that's the first problem done. Now how about the second problem? Well, as you can see, the second problem is kind of similar for this one, because as you can see, our bounds 1 when x minus 7 cannot be 7, right? 1 and 4 is completely away from 7, so this is safe to do the same method we did. So using the same method, we can know that this is gonna be the integral of 4 to 1. I don't really write it out, you guys have to know it. It's gonna be just x plus 7, right? Integrate this as normal, x squared over 2 plus 7x from 4 to 1. This is just 4 squared, 36 over 2, 18 plus 4 times that's 36, and then we evaluate it from 1. So half plus 7 is 15 over 2. So the answer is just 57 over 2, like this. It's pretty simple, right, guys? Then how about the third problem? Well, as you can see, x minus 2, that means x cannot be 2, right? But the problem here is we're integrating from 0 to 4, which passes through 2. That means this is an improper integral. We have to solve it with special case that, as you can see, it's discontinuous at 2, right? Because we can't divide by 0, because when x is 2, 2 minus 2 is 0, so we can't really do that. So we can change this into the integral of 0 to 2 plus integral of 2 to 4, like this. If you guys still wondering why we do that, because it's discontinuous, right, at 2. So we have to do this in order to solve it. Also, because we already separate the integral right now, we can just factor this out, cross. So this is gonna be the integral of x plus 2, right? Both of these. And then after having this, now we have to evaluate it with a limit. But before I put a limit there, I'm just gonna solve. And I'm gonna integrate it both sides. So this is gonna be x over 2 plus 2x 0 to 2 plus. But because this is 2, right? And remember that 2 is discontinuous, right? So we actually have to put something called limit. I'm gonna replace this 2 with a t or other variables. You guys can do anything, any variables you want. So I'm gonna solve it with like variables t and t. This is just the limit. Well, for the first one, it's gonna approach 2 from the left side, right? So I'm gonna put 2 negative here. This one also limit, but it's gonna be a 2 approaching from the right side. So it's gonna be like this. Like that, like this, sort of like that, right? So just putting the limit there, it's gonna be really simple. This first one is 2 squared 4 over 2 is 2 plus 2. So the first one actually is really simple. When t equals to 2, this is just 2 squared is 4. 4 over 2 is 2. 2 plus 2 times 2 is 4. 4 plus 2 is 6. So it's gonna be 6 plus this one. Now we put 4 in. 4 squared is 16 over 2 is 8 plus 16, that's like 10, right? And then at t, this is just the same thing as that one, which is 6, right? Which is 10. So this is just 6 plus 10. This one just 6, this one just 10. So this equals to 60. All of this I'm gonna delete. Actually, never mind. Like that. So as you can see, all of this looks similar, but this one is more complicated because we're integrating it. There's a discontinuous point. I mean, you can just solve it regularly, you can just put 2 in. But that's not how we do it, guys. We have to do it formally with limits and stuff and that. So this one is 16. So yeah, guys, you guys do this when it's not in the curve, on the line. I suppose, because this is just a line like this, like that. So yeah, thank you guys for watching this video. I hope you can, you know, differentiate which one is the imposter and stuff. If I get any mistakes, you know, you can just comment down below. And see you guys in the next video. And you guys should probably recommend me. Should I do more integrals or just one each day, you know? You know what I'm saying, right? Okay, bye guys.